So we're continuing on with our work in 7.2. Just as a reminder, on page 4 of our notes, they were giving us z-scores. They said, hey, what's the probability that the z-score is less than this number or greater than this number or whatever? They're giving you a z-score, they're giving you the cutoff number, you're looking for the area. So in your calculator, you choose normal CDF, and you're going to round your answer to 4 decimals to represent area. Some of the later problems, like on page 5, they gave us an area. They told us the area and they gave us a 4-digit number. That means we have to use inverse norm. That means we tell our calculator, hey calculator, I'm going to give you the area, you give me the z-score. Okay? So we plugged in the area into inverse norm and out came the z-score, which we rounded to 2 decimals. So keep that in mind as we're working problems. Normal CDF means you know the z-score, you want the calculator to give you the area. Inverse norm means you know the area, you want the calculator to give you the z-score. So just watch carefully for that. Also, as a reminder, inverse norm assumes that the area you're giving it is on the left. So you always have to be giving it the area to the left of your cutoff number here. Okay? All right, let's try some other examples here. Find the z-score so that the area under the standard normal curve, again, standard normal, that tells you zeros in the middle and they're counting by ones, so that the area to the right is 0.4325. Okay, now this time, instead of shading to the left, I'm going to be shading to the right. They told me the area to the right. Now, if I put my line right here in the middle, at the mean, the area should be 0.5. 50% is above the mean. But they're saying the area is 0.43. So I better scoot a little further over so that only 0.4 is to the right, or specifically 0.4325. So I'm guessing this line's going to be about right here. And this area is 0.4325. That's this shaded region here. Okay, we have an area, so we're going to use inverse norm. But remember, inverse norm expects you to give the area to the left. That's how it's set up. So if I have to give the calculator the area to the left, then I need to do 1 minus 0.4325 so that I can find the area on the left. 1 minus 0.4325 is 0.5675. That's the area to the left. So when I choose inverse norm in my calculator, I'm going to say, hey, the area on the left is 0.5675. The mean is 0, and the standard deviation is 1. And I'm choosing 0 and 1 because they told me it was a standard normal curve. Okay, so second vars, I'm going to pick inverse norm. I'm going to tell it the area on the left is 0.5675. Mean is 0, standard deviation is 1, and I paste it in and hit enter, and it tells me 0.17001, blah, blah, blah. Okay? As a reminder, this is a z-score that we're looking for. We were finding the z-score cutoff. Z-scores are always rounded to 2 decimals, so our z-score is 0.17. That's our z-score right there. Okay? Now, if you're using an 83, when you hit second vars inverse norm, it does not prompt you for these items, for the area, the mean, and the standard deviation. You just have to know that those are the numbers it wants and type those numbers with commas in between. Some of you have a newer TI-84, and here's what's kind of cool about this. If you have one of the newer ones, when you pick inverse norm and you type your back up. If you have a newer calculator, notice how it prompts you whether the tail, that means the shaded region, is the left, in the middle, or the right. So what you could do is you could have typed in 0.4325, mean 0, standard deviation of 1, and then you could arrow over and tell it, oh yeah, that 0.4325 number I gave you, it's on the right. And then when you type that in, you would get the same z-score of 0.17. So if you have a newer 84 that prompts you left, right, or center, that's fine, okay? But most of us don't have that, and so we always have to give the area on the left, so we had to tell it 0.5675. Okay, example E, find the z-score. So the area under the standard normal curve, they're telling us the mean is 0 and the standard deviation is 1. So the area to the right is 0.9713. Okay, well 0.9713 is a lot of space. It's almost the whole curve. So if I need almost the whole curve, 0.9713, on the right side, then I bet my cutoff is way down here because 0.97 is a large area, and that's going to be on the right. They told me to find the z-score, so I do not know what that z-score is. Okay, I'm going to inverse norm it in my calculator because I know the area and I'm looking for the z-score. So that's inverse norm. Inverse norm expects me to give you the area on the left. They told me 0.9713 is the area on the right. I need to get the area on the left. So 1 minus 0.9713 is 0.0287. So I'm going to inverse norm 0.0287, mean of 0, standard deviation of 1. And my calculator tells me it's negative 1.90025, blah, blah, blah. I gave it an area. Out comes a z-score. Z-scores are always rounded to 2 decimals, so the z-score is negative 1.90. And we're not surprised that it's negative, okay? Now think about why that is. Our mean is at 0 here in the middle, so when we count by our standard deviations of 1, 0 plus 1 is 1, plus 1 is 2, plus 1 is 3. So as we move to the right, we're dealing with positive z-scores. But if I subtract 1s, 0 minus 1 is negative 1, minus another 1 is negative 2. So if we're on the left side of the mean, our z-score is going to be a negative number. That makes sense. Okay? All right, another way that they could ask some questions with z-scores here. Find the z-score that separates the middle 70% of the area under the standard normal curve from the area in the tails. So again, standard normal, 0's in the middle, and we're counting by 1s. Positive z-scores on the right, negative z-scores on the left. Okay, now this time, we're talking about 70% of the area. Area is 0.7, okay? But that 0.7's not in one of the tails. That 0.7's in the middle. So there's going to be some cutoff number here and some cutoff number here, so that this area is 0.7. Well, that means there's going to be 2 z-scores. There's going to be a z-score here and a z-score here that separate our middle 70%. Well, let's see. If I've got 70% in this region, 1 minus 0.7 is 0.3. I've got 0.3 as my area for the tails. But it's not 0.3 in each tail. It's 0.3 for the tails combined. So that 0.3 is split equally between these 2 tails. 0.3 divided by 2 is 0.15. That means this tail over here has an area of 0.15, and this tail over here has an area of 0.15. Because 0.15 for the tail on the left, plus 0.7 for the tail in the middle, plus 0.15 for the tail on the right, adds up to 1 total, 100%. Okay, we're looking for these z-scores. I have areas. What I'm looking for is z-scores. So I'm going to inverse norm, and I'm going to find this one first on the left-hand side. The area to the left is 0.15. The mean was 0, and the standard deviation was 1. So second bars, inverse norm. Our area is 0.15 with a mean of 0, standard deviation of 1. We get negative 1.04. I know this is a z-score, so I'm going to round to 2 decimals. Negative 1.04. Okay, that's the first z-score over here on the left, number 1. The z-score on the right, I'm going to number that number 2. Still an inverse norm, but we have to give the area to the left. Okay, well, the area to the left of this is the 0.15 in the tail, but also the 0.7 in the middle. So all of this region over here is 0.15 plus 0.7. 0.15 plus 0.7 is 0.85. And that makes sense. If 0.15 is to the right, then that leaves 0.85 below. So we're going to inverse norm 0.85 with a mean of 0, standard deviation of 1. Second bars, inverse norm 0.85, 0, and 1. And we round to 2 decimals because remember this is a z-score. We get 1.04. Notice these numbers are the same except for the sign because that makes sense. If 0.7 is exactly in the middle and we're traveling the same distance each direction, they should be the same number, but one positive and one negative. Okay? So these are our 2 z-score cutoff numbers. Now, this is kind of cool. If you have the newer the newer 84, when you hit second bars and pick your inverse norm, you have the ability to tell it, oh, I had 70%, 0.7 was my area, mean is 0, standard deviation is 1, and then you can tell it, hey, that 70% was in the center, it was in the middle. And then when you paste it in, it's going to come up with the negative 1.04 and the positive 1.04 at the same time. So if you have the newer 84 that does that, that's cool. If you don't, you can still do the same thing with the regular 84 or regular 83. You just have to recognize, hey, I have to give the area to the left. So 0.15 and 0.85 were the areas to the left for this one. Okay, another example. Find the z-score that separates the middle 20% of the area under the standard normal curve from the area in the tails. Okay, so this time we've got 20% in the middle. 20% is not as much as 70. It's not going to be as wide as this region. This is going to be a fairly skinny region. And 0.20 is that area. Well, if 0.20 is in the middle, 1 minus 0.20 is 0.80. So there's 80% left split between these two regions. 0.8 divided by 2 is 0.4. That means this area on the left tail is 0.4 and this area on the right tail is 0.4. They are each 0.4. Notice 0.4 plus 0.2 plus 0.4 will add up to one whole. Okay? We are looking for these 2 z-scores. Z-score number 1, z-score number 2. Okay? Well, for z-score number 1, we're going to inverse norm. The area to the left is 0.4 with a mean of 0 and a standard deviation of 1. For z-score number 2, we will also inverse norm. This time, from this z-score, the area to the left is 0.4 and 0.2 combined. The entire region to the left, which is 0.6, with a mean of 0 and a standard deviation of 1. And I can type those in. Second bars, inverse norm, 0.4, mean of 0, standard deviation of 1. That score, it is a z-score, remember. It's a z-score cutoff. We had the area, so negative 0.25, and then the one on the right, the area is 0.6. So positive 0.25 are our cutoff scores for these 2 z-scores right here. Okay? So I think that takes care of our standard normal distributions and hopefully when to know to use inverse norm and when to use normal CDF. Okay? On the next video, we're going to look at some specific examples that are not in standard normal curves. We're going to be looking at specific scenarios where it's a specific set of data where we know the mean and the standard deviation, and we're not using z-scores.